All right, here we are in day 2 of section 4.7. So last time we talked about inverse trig functions. We talked about inverse sine, inverse cosine, and then we stopped right about here as we were about to explore inverse tangent. So let's go ahead and take a quick look at what tangent looks like. So we're going to graph normal tangent to start. And you'll notice I'm asking to graph it between negative 3 pi over 2 and positive 3 pi over 2. So we know that every pi over 2, every odd pi over 2, I should say, we have a vertical asymptote. So let's get this set up. All right, so I have a vertical asymptote at negative 3 pi over 2, at negative pi over 2, at pi over 2, at 3 pi over 2. All right, so I've got my scale. Every block is a pi over 4. So now when we graph tangent, we know we are at 0. We know we're at pi over 4, 1, and we're at negative pi over 4, negative 1. And that pattern repeats for all of the pi over 4s in between. And so we have asymptotes, so we follow those. And there we go. So now what we're going to do is flip all of those x and y's. And again, this is in radians. And then this is a ratio, so this is a number. And so when we flip that, now the horizontal is my ratio, and my vertical is my angles, is my radians. So there's pi over 2 and pi and 3 pi over 2 and negative pi over 2 and negative pi, and we've got 1 and 2. All right, so we look at regular tangent, and we say that there's a vertical asymptote at every pi over 2. And so that would mean on the inverse tangent graph, we would make those into horizontal lines. So we have horizontal asymptotes at the odd pi over 2s. We know that tangent of 0 is 0, so we've got the point 0, 0. We know that at pi over 4, we're at 1. So at 1, this would be 1, we're at pi over 4. And at negative pi over 4, we are at negative 1. So we're at negative 1, negative pi over 4. And that pattern continues in between each asymptote. And now I have a graph that looks like this. And it's clearly not a function because a vertical line test fails everywhere. So now what we need to do is figure out where we're going to limit our original domain of tangent so that when we reflect it over the line y equals x, and we find the inverse, I should say, we have not only a function, but we also have covered all of the values between negative infinity and positive infinity, because that is the range of tangent. So that needs to be the domain of the inverse tangent. So I think it's obvious, if you're kind of keeping up, that we're going to look at this segment of tangent right here. And so when I come down and take a look at good old-fashioned regular tangent, that section would translate to be only this piece right here. So the green highlighted part is the graph of the inverse of tangent. That's it. Okay. So what does this mean for us? This means that when we are doing inverse trig functions, inverse tangent, computer's very delayed here, that when we have a positive ratio, then we are going to be looking at an answer, an angle over here in quadrant 1, because tangent is positive here. And then we are going to look at an answer when it's negative ratio. We're going to look at an answer in quadrant 4. And you can see that highlighted in our regular graph of tangent. We highlighted between negative pi over 2 and pi over 2. So that would be this segment right here. So that means, I don't know the answer, but if I asked you to find the arc tangent of, 2.5, no idea the answer, but I know that since it's positive, it's going to be some answer in quadrant 1, some angle in quadrant 1. And if I ask you for the arc tangent of some negative ratio, that's going to be an answer that's going to be in quadrant 4, and it's going to be a negative number. Okay, so that's where we'll return our values. All right, so that officially ends the day 1 notes, but obviously we already started the second video, so I'm going to jump over and we're just going to keep on going. All right, so video part 2. All right, so reviewing from yesterday, we know that arcsine is going to return a value of an angle between quadrants 1 and 4. So we're going to get an answer somewhere in here. And arc cosine is going to return values somewhere here. And arc tangent is going to return values somewhere in the same range as sine. Because they're different, simply because sine is positive, positive, negative, negative. So to get all the full range of positive and negative possibilities, we can accomplish that right here in quadrants 1 and 4. And here we've got positive, positive, negative, negative. So the same area, the same region doesn't work as it did for sine because I've got positives in quadrant 1 and quadrant 4. So it will return answers from 0 to pi. And then arctangent, since it's positive, negative, positive, negative, we are going to use negative pi over 2 to positive pi over 2. All right. Let's see what we're going to do next. All right. Example 1. Now we're just going to practice what we've learned. Arc sine of a negative root 3 over 2. What angle has a sine of negative root 3 over 2? So I think about my unit circle, or I draw a little triangle. Either way, I figure out that that is talking about a pi over 6. Nope, pi over 3, excuse me, angle. But it's a negative root 3 over 2. That means we're talking about an angle over here or over here. And we know that arcsine is going to return a value here in quadrant 4 when it's negative. And so the answer is going to simply be negative pi over 3. Arc cosine of negative root 3 over 2. The answer here, cosine is going to be negative over here. So we're looking for values somewhere in here, but since it's negative, we're going to be in quadrant 2. So what angle has a cosine of negative root 3 over 2? That would be pi over 6. So we're looking at the pi over 6 angle that's in quadrant number 2. And that would be 5 pi over 6. Arctangent of negative 1. The arctangent of negative 1. So usually what I'll do with tangents is I'll sort of dump the unit circle for a minute, and I'll just draw a triangle. So if my tangent is, I'm just going to worry about 1 for now. If my tangent is 1, we know the opposite divided by the adjacent would both be 1s, and that tells me this is an isosceles right triangle. So we're talking about an angle of pi over 4. So what pi over 4 angle has a negative arctangent or a negative tangent? that's going to be one that's down in either quadrant 4 or quadrant 2, but arctangent's going to give us the answer right here. So theta equals negative pi over 4. Okay, this next question is more of a kind of just an intellectual exercise. It's not really a practical use of the arcsine and sine. But if we look at this, we know that the sine of pi over 6 is going to be some ratio right here. And then when I take the arcsine of the sine, that just undoes that. So sine of pi over 6 is a half. So now this is saying, hey, what angle has a sine of a half? Well, obviously that's going to be pi over 6. Arc cosine of the cosine, you would think, just cancels each other out, and we would get an answer of negative pi over 6. But that doesn't quite work like that, because let's take a look at what we're dealing with here. So arc cosine of negative pi over 6. So we're going to open up this way, pi over 6. So the cosine is going to be the root 3 over 2. Okay, so the cosine of negative pi over 6 is equal to positive root 3 over 2. Well, what other angle? Because now the question is saying, what is the arc cosine of what we just got, root 3 over 2? And it doesn't know that you just use negative pi over 6 to get the root 3 over 2. So it doesn't know that. So what we have to do is strictly go by what we talked about, which is it's going to give the answer that is in quadrant 1 or quadrant 2. So it's going to give this answer right here. So if we ask the calculator the question, what is the arc cosine of root 3 over 2? It's going to give me an answer of pi over 6. Because it also has the same cosine as negative pi over 6, but arc cosine gives me the answer in quadrant 1 and quadrant 2. Arctangent of 1 over the square root of 3. I'm going to draw a triangle. I'm going to label a theta. Arctangent, so tangent of theta would be 1 over the square root of 3. So it's asking me, hey, what's this angle? That angle is 1, 2 square root of 3. Okay, this is a pi over 6 angle. So now it's a positive, so I know it's going to return an answer of pi over 6 from quadrant 1, which is pi over 6. All right, and then the last one, I'm going to ignore the negative for a minute, just figure out my triangle. Here's theta. This would be root 3 over 1. This is still a 30, 60, 90, but this time I'm looking at the 60. So we're looking at pi over 3. Okay, so the answer is pi over 3, except the fact that it's negative tells me I'm actually looking for the pi over 3 angle that is down here in quadrant number 4. So my answer is going to be negative pi over 3. Positive and negative. So what angle has a negative root 3? It's this triangle right here. There it is. But it's the one in quadrant 3, so that means it's negative pi over 3. All right, I hope this is making sense. Let's keep going. It's getting a little late in the day, so I'm going to try to speed this up. All right, so now let's look at these questions very carefully. It says use a calculator to find the principal solution and then use that answer to find all the answers between 0 and 2 pi. Okay, so what is this talking about? This is saying that we've got some angle sine, right? So some angle sine that is 0.35. So that means I've got some triangle where here's the angle. This is 0.35. This would be 1. And I take a step back and I'm like, oh, I have no idea. This is not one of my known triangles. And this is why we now need to use our calculator. Okay? So then the question is, what are we going to do in our calculator? And the answer is we're going to use the inverse sine. So before we do that, let's take a quick look at this equation. if we are going to apply algebra to this equation, and I want to get x by itself, because once I do that, I'll know the answer. So this is going to be very reminiscent of what we've done in the past. It's just going to feel a little bit different. If I want to isolate x and get x by itself, I need to get rid of sign. But a lot of people are going to say, should we divide by sign? That'd be great, except sign is not multiplication, so dividing does nothing. We need to do the inverse of sign. And the inverse of sign, of course, is the inverse trig function, the arcsine. So, algebraically speaking, what would we write? We would write, let's take the inverse sine of what? The left side. And then we would take the inverse sine also of the right side. And the inverse sine of sine, they cancel each other out, just like a square root and a square or a logarithm and exponent. The sine and the inverse sine cancel out, leaving me with x equals, and now I need to answer this question. But since I'm looking at this question, this is going to return one answer. It's not going to find me what it's looking for here, all the answers between 0 and 2 pi. It's going to give me one answer, and then I need to use my brain to find out all the other possible answers. So let's attack this as a degree question first. So let's change these instructions, and let's think about doing it from 0 to 360 first, which means we better make sure our calculator is in degrees. All right, I did not set up this video to record my calculator, so I'm using my handheld calculator. But I'm going to double check first that I am in degrees, and I am not. So let me switch that. Okay, so now I'm going to find the inverse sine of 0.35. So I'm just going to do second function sine, 0.35, which basically says, hey, look up the angle that has this sine. And I get an x that is approximately equal to 20.487 degrees. So now that is the answer to the first part. Find the principal solution. That's the answer the calculator gives you. But now I need to use my brain and that answer to figure out all of the answers between 0 and 2 pi. So what I've just found, of course, looking at a let's not use a unit circle here, looking at a coordinate plane, I've found that this answer right here of 20-ish degrees has a sine of 0.35. Well, what other angle has a sine of 0.35? It would be this angle right here. That would also be the 0.35. So that means this is also the 20-ish degrees right there. So what angle would that be from standard position? It would be approximately 160 degrees. More precisely, it would be 180 degrees minus the 20.487, or we would get, what is it going to be? 159 point, let's see, 513 degrees. So you can see how the principal root basically finds you the reference angle, at least it did in this case. And then all I need to do is answer now the question, when is this going to be positive? And that's going to be in quadrant 1. So the 20 degrees is the answer, but also in quadrant 2. So the supplement would also be the answer. If I wanted to do this in radians, then I just repeat this process, except my answers will be in radians. So if I continue with this, and now let's answer it in radians. Then when I do the arc sine of 0.35, I'm going to go back to my calculator, and I'm going to go to radians. Now I'm going to rerun the inverse sine of 0.35, and I'm going to get a different answer this time because I'm using a different measurement. I get an answer this time that x is equal to 0.3, approximately equal to 0.35, looks like 8 if I round to 3 decimal places. So don't forget this is now in radians, where, 1, pi over 2 radians would be right here. And pi is 3.14 divided by 2. So it's like 1.57, right? So we're 0.3. Now we just did it in degrees, so we know that that answer in degrees is 20 degrees. So we're looking at an angle of 0.358 radians right there. So what other answer would we get? We would get the answer over here, where this is 0.358 radians. And what is that angle? It's still just the supplement. So x equals pi 180, right, minus the 0.358. So I'm going to subtract from pi, and I get approximately equal to 2.784 radians, right? We don't have a symbol for it. So that's my two answers that we would get. We're used to radians being in terms of pi, but these answers are not in terms of pi. All right. Hopefully this is going okay. Let's just do this one in radians for this one. So the question is, what angle has a cosine of negative 0.65? So if I do the inverse cosine of both sides, I get x equals the inverse cosine of negative 0.65. Now, I should expect an answer to that question that's in quadrant 2 because the ratio they gave me for cosine is negative, and I know it's negative in quadrant 2. Now, I'm in radians, so it may not be perfectly obvious that we're in quadrant 2 when we do this. Let's find out. The inverse cosine of negative 0.65, I get an answer of x is approximately 2.78. Looks like 702. Oh, that's a lie. Let's try that again. 2.278 radians. All right, so now we got to think about what we just found, because that is not a reference angle. This is going to maybe blow some of your minds, but let's just stick with it here. So what I've just found out, I've asked it when is cosine at negative 0.65. So if we think about a unit circle, 0.65, halfway would be 0.5. 0.65 we'll say is about here. So we're looking for that. And what we just did when we did the inverse cosine of negative 0.65 is we got this answer, which is 2.278 radians. Okay, so now we go back to the question. Find all the values that satisfy this equation. So what other angle is going to have the same cosine as this one? And that's going to be an angle right here that has this same reference angle. So what do I need to do? I need to figure out what is this angle measure right here based on my original problem. And that would be, so let's find the reference angle. So we're going to call that theta prime. So what is theta prime, this angle right here? It would just be the supplement, pi minus 2.278, or let's see, minus, and that would be approximately 0.863 radians. So now, what is the angle I want? I want the one that's going to start at 0, standard position, and wrap all the way around to here. One of the answers we found, that's that many, and that was 2.278. But then the other one's going to be what? Pi plus the reference angle. So the other angle is going to be x is approximately equal to pi plus 0.863. The reference angle is 0.863, and I'm going to add that to pi. Which gives me x is approximately equal to 4.005 radians. Now, this seems probably hard and confusing, but it's only hard and confusing because we are using kind of a non-standard version of what we've been doing. Like if this was pi over 6 and pi over 3, this would not be hard. So if we redid this problem, answering the question, but let's say, the question in doubt, let's say that the answer was, again, I'm making this up. Let's say that when we did this initial problem, we got an answer of, who cares? We'll say we got 11 pi over 12. Okay, so this angle right here, let's pretend is 11 pi over 12. What other angle would it have? So I just now got to figure out, again, what's this angle? That would be, in our case, pi over 12. And I need to add it to this side. So that would be 11 pi over 12, 12 pi over 12, 13 pi over 12. Okay? It's all nice and easy when we're talking in terms of nice, friendly radian numbers. But what we just did here with fake numbers is exactly what we just did on the problem B. We found the angle in question, 2.278 radians. And then I said, just like I did over here, I said, okay, then what makes up the rest of that? That would be 0.863. Then what do I do with that? I need to find 0.863 beyond pi. And so I added them together. If all you're looking for is what do I do when it looks like this, then you're in big trouble. But if you can think outside of the box and just really understand the concepts, then this really isn't that hard. Okay, I don't know if I convinced you, but it's true. All right, let's see what else we're being asked to do. Example number 3. Evaluate this question. The cosine of the arcsine of 3/4. All right, so I think we need to just slow it down and see what this is asking. So let's focus on the interior here. What angle has a sine of 3/4? I don't know, but let's draw the picture. I'm going to say it's right here. There it is. Now, it's only going to be this angle if what's true. This is 3 and this is 4. So what angle has a sine of 3/4? That one does, right there. I found it. I don't know what it is, but I found it. If that's where the question stopped, then we'd be in trouble and probably have to use our calculator. We don't need to use our calculator because now what is this asking? It's now saying, find the cosine of that angle that you just found. Well, I can do that without ever knowing what the angle is because I've got this right triangle. So what is this side length? It would be 16 minus 9. This would be the square root of 7. Okay. 16 minus 9, what am I doing? I'm saying 3 squared plus I don't know squared equals 4 squared. So I've got 9 plus a squared equals 16. A squared equals 16 minus 9. A squared equals 7. A equals the square root of 7. So now what's the cosine of this angle? The answer would be root 7 over 4. So I never actually had to know the angle to find its cosine. Let's take a look at the next one. The secant of the arctangent of 3/5. Sounds hard. It's really not. So this says find the angle. So I'm going to find it. Here it is, as long as that's a 3 and that's a 5. Because then my arctan, my tangent of this angle is 3/5. So it says find that angle, found it. There it is. Now, what's its secant? Secant is going to require the hypotenuse, which I do not have. So I'm going to do 3 squared plus 5 squared equals c squared, or c equals the square root of 9 plus 25. That's 34 which is 2 and 17 doesn't reduce. This is the square root of 34. So find the angle. There it is. I found it. Now, what's its secant? Secant is reciprocal of cosine. So the secant is going to be square root of 34 over 5. What else we got today? All right. Example 4. Write an algebraic expression in terms of x that is equivalent to this problem. This is just like what we did a second ago, except we don't have a number, we have a variable. All right. So what is this saying? Find an angle, right? That's what this says. Find an angle that has a sine of 2x. So once again, just like I did in the last problem, I'm going to say, here's the angle I'm looking for. And if it's the angle I'm looking for, then the sine has to be 2x, meaning this has to be 2x. This would have to be 1, because if I find the sine of this angle, it would be opposite over adjacent. Over hypotenuse, which would be 2x over 1. So if that was the end of the question, I don't really know what to do. I would just like point at it and say, here. But now what is it asking me to do? It's saying find the cosine of the angle. So the cosine would require me to find the adjacent side. So I'm going to have to do that. Even though I've got a variable, it's fine. We're going to do a squared plus b squared equals c squared. So I've got 2x, the quantity squared, plus unknown squared equals 1 squared. So I have 4x squared plus b squared equals 1. I have b squared equals 1 minus 4x squared, and I take the square root, and I get the square root of 1 minus 4x squared, which I cannot simplify because they are terms. So this is going to be 1 minus 4x squared. So now it says, okay, find the cosine. So the cosine would be adjacent over hypotenuse. So the answer is going to be 1 minus 4x squared, the square root of that. Technically over 1, right? But we don't need the over 1. All right, let's see what else. I think this is our last example. All right, evaluate the cosine of the arcsine of 2x for x equals 1/4 and x equals 0. All right, so before I answer this question, I'm going to go back and see how it relates to my previous question. It is the same question. We said that the answer to this question could be found simply by doing the algebra we did a minute ago. So we could approach this two ways. We could just plug in 1/4 and do the math from scratch. So option A, which I don't recommend doing, but we can do, find the cosine of the arcsine of 2 times 1/4. 2 times 1/4 is 2 times 1/4 is 1/2. And so the arcsine of a half is going to be pi over 6. So this question says find the cosine of pi over 6, and the cosine of pi over 6 should equal what? Root 3 over 2? So the answer should be root 3 over 2. Option B. Since I just asked you this question up here in example 4, so from example 4, we said the answer to this question was 1 minus 4x squared. So this should mean that we have equals 1 minus 4, but what's x? It's 1/4. So I get 1/4 squared, which gives me the square root of 1 minus, we have 1/16, but I have times 4, so that should end up being 1 minus a fourth, which should end up being 3/4. And when I take the square root of 3, I get the square root of 3. And when I take the square root of 4, I get 2. I get the same answer. So I can just answer this question by plugging in x, because we already did it algebraically. So I plug in 0, and I get the square root of 1 minus 4 times 0. I get the square root of 1. I get 1. Or we could do it like option A, and we plug in 0 to this question, right? So we plug in 0, we would have the cosine of the arc sine of 2 times 0, which is 0. And the arc sine of 0 is asking what angle has a sine of 0, and that answer is 0. So now it's saying what is the cosine of 0, which we know is 1. So option B, as long as we already did that algebra, you can see we can get the answer just by doing algebra. Option A, had you not just previously done that, then yeah, we would do option A instead. All right, I hope we're getting the idea here. I do want to say one time here, and I've said it in class, but for the most part, we are going to use the inverse trig functions for what you would expect us to do, which is, hey, what angle are we looking at? And so 90% of the time, you're going to be using it like we did right here. We're going to mainly do what we did on these problems. What's the angle that has this ratio? And then you find it and you're done. Okay? The rest of this is, again, making sure you understand the concept very completely and to do some problem solving activities. All right, that's it. I'm going home.